the radians of these angles. And like I get the general sense of how to do it, but it's still kind of confusing to me on how to to do it still.
Okay. So for number one, you're gonna take the cosine inverse. So the cosine of theta equals negative 0.12. So to undo the cosine, you would do the cosine inverse, right? The
Hmm.
cosine inverse of each side will get rid of that. So theta equals the cosine inverse of negative 0.12. The difference is there's going to be actually two answers for that, and your calculator is only going to give you one,
Hmm.
right? So think about where the cosine is negative. Remember, this means what angle has a cosine of negative 0.12. And remember, cosine is your x coordinate, right? So it's going to
Hmm.
be in this quadrant and in this
Yeah.
quadrant.
Hmm.
Your calculator is going to give you this answer right here.
Hmm. Okay.
Got it? So you need to find this answer, change the color. You need to find this answer right here by calculating. There's a couple ways you can do it, but by calculating the reference angle and then adding that to 180, okay, or to pi. Remember, this is pi. Follow what I'm saying?
Yeah. So
So when you punch cosine inverse of negative 0.12, what does that give you?
I got 1.691.
Right. So 1.691 approximately is that answer is the red answer, right?
Yeah, the
That's
red
this
one.
one. Yeah. And so take pi, subtract that from pi,
So I would put in my calculator pi minus
pi
1 point.
minus that. Yep. Pi
Okay.
minus that answer.
I
And
got
that gives you this number.
hmm
That gives you your reference angle.
and then we
And then you want to add pi back to that. Very
add
quick way to do that.
pi to the one. You want me to add pi to the one I just subtracted to?
Yeah.
Okay.
And that gives you the blue one.
Interesting.
Do you understand why? So pi minus 1.691 gave you 1.4505 roughly.
Hmm.
And then add pi back to that. So if I think about really what I'm doing is I'm just adding 2 pi. I'm taking 2 pi minus that number. That's another way to think of it.
Okay.
Oh, that doesn't make sense. 2 pi. Is that really what I'm doing?
Hmm.
Why am I having a hard time visualizing what I'm doing there? So your calculator, the cosine of is negative 0.12. You know that that's going to be in the second quadrant, right?
Hmm. Yeah.
But there's another cosine. There's another place where the cosine is negative right there.
Yeah.
So you're finding that same angle basically. That's the same one, right? That's the same cosine, the same reference angle.
Oh, yeah.
You follow what I'm saying? That
Hmm.
that black line is the same, or that black angle is the
Oh,
same. So that's why you're doing it like that.
okay. Now I understand. Okay.
So your other answer is so your one answer is that, and your other answer is 4.592 approximately. Let's just check that to make sure that's right. What's the
Hmm.
cosine? What's the cosine of that number? Plug that back in.
So
You should get negative 0.12.
cosine 4 point um 5921 negative 0.119999. Yeah,
Yeah.
basically negative 0.12. Okay.
Yeah, so really it was just the same as just 2 pi minus that.
Okay. Two. Let me try that. 2 pi
Yeah,
minus
that
one
that is the
point.
other way that you could think about doing it. You could just take 2 pi, like think about what you're doing. You're taking your
The full circle and you're subtracting it.
yeah, and you're subtracting it. So you're going back this direction. That same amount. That's the other way you could think of doing it, which maybe your teacher taught you that. See, I should have made that red.
He taught us both ways.
Yeah.
So
Do you get what
which
I'm saying? You could
yeah.
go, you could think instead of going the full circle around and then subtracting this red angle back. That's the other way you could think of it.
Mm,
I like to draw the picture out each time and just think it
yeah.
through, like I showed you, but you could do it that way too. Some people like to just memorize formulas and then just do them. The problem I have with that is the formulas kind of are different depending on what trig function you're dealing with.
Yeah.
So in my opinion, it's better just to understand what you're doing. So let's look at number two. The cosecant of theta equals 5. So we're taking, that means the sine of theta equals 1/5. I always like to turn them into sine
Hmm.
if you can. So that means the sine inverse, let me change my color here. Theta equals the sine inverse of 1/5. And again, what does that mean? Well, the sine is your y coordinate, so it's your answer. It's positive. There's going to be one here and one here.
Hmm.
So this is the answer that your calculator is going to give you.
Yeah.
But then you have to find the other answer, which is right
So
here. And these two angles are the same. That those reference angles are the same. So for that one, it's going to be pi minus. It's going to be pi minus
pi minus.
the red that you get. Does that make sense? So do
Okay.
sine inverse in your calculator,
Yeah.
sine inverse of 1/5, and of course make sure that it's in radians, of course,
Radians. Yeah.
which I know you know I know it is for you, but if anyone's watching this, oops, make that red. So your red angle is equal to approximately 0.201, and just leave that whole number in your calculator. And so then I'm gonna find the other one. I'll make it black. I'm gonna find this. I'm sorry, I did that wrong. That should be purple. My purple angle is approximately 0.201. That's the purple one right here.
Hmm.
But the red one is going to be equal to, the red angle is going to be equal to pi minus 0.201. So use your calculator, punch in pi minus, and then throw that whole number back in so you get the exact answer, which is 2.94 approximately.
Yeah. Hmm. So to
And
know
again,
whether
you can check it by doing that same thing I told you. Take the sine of that angle, and you'll get 1/5 or 0.2.
yeah.
So you always check your answer just to make sure. Your calculator might give you 0.199999999, but that's 0.2 essentially.
Okay. So to solve these questions, you would kind of need to know the range of the sine and cosine.
Correct.
Yeah, because I was kind of confused, like how would you know when to use 2 pi minus the number or pi minus the
Mm-hmm.
number?
Well, also, yeah, you just want to know what it's giving you, what your calculator, that's right, your range, what's your calculator giving you. So remember the different things. The sine, the sine is defined, or the sine inverse of theta is defined between here and here, negative pi over 2 to positive pi over 2. That's the range of your sine inverse function. Okay. The cosine or the cosecant inverse function is defined similarly, but the difference I'm going to use a dashed line for that. The difference is it's not defined where the sign equals 0, so you have to put a hole there,
Okay.
right? And the sign equals 0 at 0, right?
Hmm.
Does that make sense?
Yeah.
The tangent inverse, remember the tangent isn't defined here and here. So the tangent inverse is defined from here to here, but not including pi over 2 or negative pi over 2 because it doesn't exist there.
Okay.
You follow?
Yeah.
The cos, the, so what am I missing? The cosine inverse is defined from here to here, from 0 to 180, right?
Hmm.
And the cosecant inverse, or sorry, secant inverse, the secant inverse is defined in the similar way, but it's not defined at where the cosine is equal 0. So
Okay.
it's like this.
So for the secant and co for the secant and cosecant, are the
I guess
points on the axis?
I got plenty of colors. I could have just defined that with a colorful one instead of trying to be crazy. So let's redo that.
No.
So the cosecant inverse function is defined. Oops, I wish I didn't erase that line.
Oh.
I have to put that red line back in there. Okay, cosecant inverse is defined. I forget what color I was using.
Purple?
Purple, darker purple.
Yeah, that darker
It's
purple.
not defined here. It is defined here, and it is defined here.
Okay.
So it's
So
not defined where it's equal to 0 because you can't divide by 0, right? I think
yeah,
that's right. Right? Isn't that what you've got in your notes?
yeah.
That seems correct to me.
Hmm.
Let me just look it up real quick. Cosecant inverse function.
Hmm. So
Make
the
sure I'm not
only
telling you the wrong thing.
so the only trig where the numbers aren't included is inverse tan. Okay.
Oh, cotan. Yeah. Wait. Inverse cotan. No, we can do that one too. So the inverse cotan is going to be. Um, I'm missing that one, aren't I?
Oh yeah. I just
Yeah.
realized that.
Yeah. The inverse cotangent function is, think about what the cotangent is. It's positive, and it's, see, the way you can think about this, the way you know where it's going to be defined is you got to think about when the sign is positive and when it's negative, because you have to have a positive and a negative. So for the cosine, it can be defined here and here. For the cosine, it can be defined from 0 to 180. They're continuous,
Hmm.
right? But because you get your positive values in the first quadrant and your negative values in the second quadrant. You
Hmm.
follow what I'm saying?
Yeah.
But and same with the cosecant. But for all the other ones, you get their um well, for the tangent and the cotangent, you can choose either one. You could choose to go from um you could choose to go from 0 to 180 if you want, but if you think about where it's defined, the tangent isn't defined pi over pi over 2. So we want it to be continuous. If you looked at the graph, look down at the bottom here. I'll show you what I'm talking about. If you look at the graph of the tangent function, where do you remember what it looks like at pi over 2 and negative pi over 2?
And it would do like
What color did I use for that? Purple.
dark purple.
So light purple.
Yeah.
So it goes like this. Remember that? It goes like that
Yeah.
for the tangent. So do you remember how you define an inverse function? You take the graph and you flip it over the line y equals x. So the inverse function of this would look like a, the graph would be flipped over the line y equals x, which do you understand what I'm talking about?
Mhm.
Which is like a line like that. So the graph of the inverse function would look like, I'll make it pink. It would look like this. That's the inverse tangent function, roughly.
Mhm. Yeah.
That's the tan inverse function. Am I doing that right? Yeah.
Mhm.
Yeah. So there's a limit of, thinking of that right? Yeah, I think I'm thinking of that right. You want me to keep explaining, or is it
Yeah.
confusing you? Okay.
No.
So let's look at the cosine or the sine function. This is going to make it a little bit clearer for you. So
Mhm.
if the sine function, the sine of x looks like this. It goes from, it's one, that's negative one, and it starts in the middle and it goes up, down, up, down forever, right?
Yeah.
So if we want to find the inverse, we have to choose basically a domain of this graph to use to flip it. So what domain are we going to choose for this graph? We're going to choose the domain of, let's see if I can get my
Wouldn't it be like negative
shape.
1 to 1?
We're gonna choose the domain to be from here all the way to there. We're gonna choose that domain because that's from negative one over two, pi over two to positive pi over two. Now, when I flip that, what that domain, I will um, I will have all of the values to be able to be defined for the
Hmm.
sine inverse. So if I want to find out when the sine inverse is negative one, I think I just graphed this too far on the top one, the tangent. I think I graphed it too far. If I want this to be negative one, sorry, one half, where is the sine equal to positive one half? Well, your answer is right there. That's where it's equal to positive one half, which was 30 degrees, right?
Hmm.
Pi over six, sorry,
Yeah.
pi over
Pi over
six.
six. Pi over
That
six.
was your answer. It could have also been over here, right? If it was over here, right, that would have been 90 degrees away from pi over six. That's in the second quadrant, but I don't want to be able to remember for it to be a function. It has to be 1 to 1. You can't. This isn't a
Hmm.
function. A sideways parabola isn't a function because you get two values for the two y values for the same x value. So you have to pick. You have to pick the domain of the original function. You have to
Hmm.
define that or refine that, restrict it, like I did with that highlighted portion.
Hmm.
You get what I'm saying?
Yeah.
That's why we do that for the sine. Now let's look at the cosine graph. If we did a cosine graph, the difference is it starts up here. It's the same graph as the sine, it's just shifted,
Mhm.
right?
Yeah.
There's your cosine graph. And so now we have to pick something. Well, now if I did the same thing I did for the sine, that wouldn't work because if I defined it from here to here, notice how that when I flip it, it doesn't pass the vertical line test. It's like a sideways C.
Yeah.
So I can't pick that. In fact, I wouldn't want to pick that. What I want to pick is from 0 to there.
0 to 1.
Oops. Zero. No, sorry. Let me redo that. I'm like trying to be fancy. From 0 to pi.
To pi.
I'm defining it from 0 to pi. In other words, the first quadrant and the second quadrant, right? This is where the second quadrant starts.
Okay.
if I'm looking at this in terms of quadrants. This is my first quadrant, this is my second quadrant, this is my fourth quadrant going backward. This is my third quadrant, this is my fourth quadrant,
Hmm.
and then it starts over again, right? This is my
Yeah.
first quadrant, right? This is just repetitive. That's what, so what I'm doing is I'm taking one portion of that graph and making sure I cover all of my bases. You see
Hmm.
how all of my the range is just from negative or from one to or -1 to 1, right? The
Yeah.
range of a sine function. So I'm basically just covering all of that.
Okay.
What's the range of a tangent function? A tangent function, what's the range of this?
The
It's from
range.
-infinity to infinity, right? That's the
Yeah.
range. So the range of the tangent function is equal to the domain of the tangent inverse function. So the tangent inverse function has a domain from -infinity to infinity. So it was what I said. This graph was correct. The red graph that I put in there. That is
Yeah.
the tangent inverse function. It has an infinite range. The sine function, the cosine function has a limited range.
Hmm. Got it.
Does that make sense?
Hmm.
And you could do the same thing for all those different things. So back to this. So where is the cotangent defined? Well, the cotangent, we're going to have to look at the graph to understand what this does. The cotangent graph, do you remember what it is? It's it it has asymptotes from 0 to pi to negative
Hmm.
pi. Do you remember
Yeah.
that?
Hmm.
So this graph goes like this, and it's this way.
Hmm.
Remember that?
Yeah.
So that's what we're going to have, but it's not defined where it's equal to 0. So see how the tangent function looked? Um, wait, does the tangent function, let me think about this for a second. Is the tangent function defined at, yeah, it's defined there. Never mind, I'm good. It's not defined at the endpoints. It's not defined at the endpoints. So the cosecant function, dark purple, right? Dark purple. The cosecant function is defined from here to here, but not including the endpoints.
Okay.
So the cosecant function, let me see if I can do this little trick. The cosecant function and the secant function and the cosine function are all defined essentially from 0 to 180, give or take
180.
an endpoint or two or a midpoint, right?
Hmm.
And these three are all defined. Um, yeah, those three are all defined. Wait, did I do that right?
Yeah. Um,
No, I said
Sine,
cos. I
cosine,
should have
cos.
said co. Sorry, I did that wrong. That's wrong. Sorry, I made that color the wrong color. That last graph, I made the wrong color. That should have been gray because I was talking about the cotangent, not the cosecant. I was saying co.
Hmm.
I meant to talk about the cotangent, right? So
Yeah.
these three are all defined from 0 to 180, give or take. And these three are all defined from -90 to 90,
Hmm.
give or take an endpoint or a midpoint.
Yeah.
Make sense?
Yeah.